Hi, my name is Afrah. Me and my teammate Cristian will be presenting the one-handed phone case design. We'll go over our motivation, the design process, and the conclusion. Modern smartphone devices generally only have a few external actuators like the volume and power buttons. These can possibly be interfaced through the touchscreen technology we are familiar with, but at the expense of other features. For example, the assistive touch on Apple devices and one-handed mode on Samsung devices both obstruct the display area. The power and volume buttons are always in the easiest places to reach, and this could impose limitations on the single-handed user. The inconvenience locations on the buttons could limit the freedom of the single-handed user's interaction with their device. For example, a single-handed user might avoid purchasing a larger device, even if it was if it had some qualities that they valued simply because the size would be an inconvenience for them. We came up with a solution of designing and 3D printing a phone case that uses slider actuators in a more convenient location on the case, which would allow the single-handed user to reach the volume and power buttons on their smartphones without having to hyperextend their fingers or completely shift their grip on their device.
This is the 3D model of the phone case that we designed using SolidWorks. The case we designed was for Apple's iPhone 13 Pro Max, and we were able to obtain all the necessary dimensions for the design directly from Apple design guidelines. The first two images on the left show the front and back sides of the case, which are pretty standard to other protective cases for this device. However, the two images on the right show the guiding rails for the sliding actuators that we proposed for this design. A closer look at the inside of the case on the far left here reveals the main design points of this case. The interior of the phone case contains a void space where the sliders would assemble to the case in a controlled area that would allow for free motion of these sliders while also producing enough pressure between the sliders and the phone case and the buttons to activate the intended functions. The images to the right of the interior of the case show the design of the proposed sliding actuators. In the middle, we have the power button slider, which was a simple design, and on the far right, we see the volume slider. The volume slider was modified to include a cutout space on the contact surface to ensure that the volume down button would not be simultaneously activated when trying to activate the volume up button. This was one of the main challenges of this phone case design. So in conclusion, our project is significant because it was not necessarily influenced by market appeal, and instead we chose to focus solely on developing a useful tool for the one-handed phone user. Unfortunately, we realized that we made a mistake when printing the final product, and the initial 3D print will have sliders that are just a smidge too thin, about half a millimeter too thin, and they won't be able to activate the volume and power buttons. However, we do plan to reprint these and test them and include the results in the final report. For the future, we aim to put this idea to good use in the real world, and an extension of this project would be to potentially design similar phone case with sliding technologies, but for other phones such as the Samsung Galaxy devices or even the popular OnePlus devices. The final product of our initial 3D design will be available early next week, and we plan to test the effectiveness of our design and include those results in the final report. Thank you so much for attending our presentation and contact us with any questions.